I've been doing it for about 30 years. In that 30 years, I've known John for about 25 of those years, almost 30. So we brought him up to discuss some of the repair methods. He's very familiar with grout injection, cementitious waterproofing, bentonite, and some of the other ways to fix the most common waterproofing problems. And so I think that'd be a good thing to have John involved. John's got over 25 years of experience in chemical grout. He graduated with a BS, that's a Bachelor of Science. Not to be confused with other construction degrees. He's got a BS in chemical engineering from the University of Texas in 1965. When I was 5, he graduated. I was a little concerned because when I moved my car across the street, I saw John came in and he had this here. And I thought, I didn't see the whole thing. I said, shit, he's on oxygen. But he's not. It was just his stuff. So that's good. He's an active member of a lot of different trade organizations and has been over the years. And he knows a lot of stuff. And the neat thing about when you get to that age, and I think it's anything over 50, you can't lie anymore because you can't remember the lie. So you have to speak the truth, and you don't really care what people think once you tell them the way it is. So John's got a lot of that, and that's good because you get the raw story without all the BS behind it, except for his degree. But before John speaks, I want to talk a little bit about how we get leaky buildings. And we're on both sides of it. We're on the new construction side and we're on the restoration side. And if you stay in it long enough, you get to fix the buildings you screwed up the first time. And that's awesome if you can get paid both times. Of course, that time frame of 10 years for the statute of limitations has to expire. Because if they ask you to fix the building before the 10 years statute of limitation expires, they normally don't pay you the second time. They ask you to involve your insurance company and your bonding company. So there's a vested interest for all of us that build new buildings to do it right the first time. And it's not a solo operation. I cannot put waterproofing in correctly. If it's not designed correctly, if the products aren't manufactured correctly, if they're not stored correctly, if they're not installed correctly, and if that work isn't coordinated by the general contractor with all the other trades that can mess it up. Today I was going through some pictures and I said, hey, I got some really good pictures of some projects that are screwed up. But half the guys in here, they're your jobs, man. So I said, well, I don't want to do that. I'd have to delete the name of the job and all that. I'm kind of half kidding. But so there's projects that have problems, and we learn from those. We look back and say, boy, that's a good lesson learned. So what we've done is we've put together some lessons learned that we're going to start to show on our website. Not only do we have like 30 lessons learned topics, like for air barrier. How do you screw up an air barrier job? Well, let me tell you, it's pretty easy to do. So we're going to have our lessons learned PowerPoint for our clients. If they want to look them up, they can say, hey, can I have the password to look at your lessons learned library? Because I gave this job to the low bidder. And I want to know what to look for before I have to tear the skin off the building and redo it. And so we want to keep those. And for ourselves, too, it's like some of the problems I see, I go, how can we keep doing the same thing over and over again? Well, because it's not written down in any book. I mean, there's a book where you could look up some stuff, but in here it doesn't show you how somebody could do the same thing 10 times in a row in putting an air barrier on or below grade waterproofing. So some of the resources that we use the Sealant Waterproofing and Restoration Institute. It's a great organization for waterproofing and restoration people to get together and say, hey, here's my project. It was a nightmare. I lost my ass and it wasn't a good deal. Or, hey, here's a project I did and I had to do it a second time because I did it wrong and it cost me $1 million. We have engineers there that come and say, hey, here's a job I designed incorrectly and I had to go back and redo it. So that's refreshing to find out how it's done wrong so you don't have to repeat it. So we use educational venues, whether it's University of Wisconsin's got a great couple courses on waterproofing, whether it's the Sealant Waterproofing and Restoration Institute. We put some of those in about 12 different cards that we call quick cards. that show how to install waterproofing or air barrier or flashing. We have them in Spanish and in English. We have a section in here for safety information, preparation information, installation information, and then inspection information. So somebody could look and say, hey, I don't know much about it, but I need to read this and say, well, is that a 12-inch overlap? Is that a 6-inch overlap? Things like that kind of help out in the construction process. I like giving these to people, say, here, feel free to go and see if we're doing it correctly, because that's free inspections and oversight I get. And I'd rather have it happen before it gets backfilled, because once you do backfill it and cover it up, it's very hard to fix. And that's why John's going to show us what we can do to fix it. So it's a collection of things that we're going to have on our website that people can download, including the quick cards, the lessons learned library, and also a building envelope checklist. I had a client that came to me and said, you know what? We keep doing the same thing over and over again. You guys come in and do your stuff, we screw it all up, we build a building, it leaks like hell, and then we try to sell it before anybody has to go fix it. Is there any way we could stop that process? And could you put together a checklist of stuff we're supposed to do? And so I thought, well, you know, that's really not my job. I'm not a designer, just trying to furnish and install. But yeah, we can do that. So we put together a checklist, and it'll be on our website as well. Or John Black actually put this together, and we had a couple of engineering firms vet it. Things like slope of the concrete. You know, are you sloping all the concrete on the site to the building? So if you do that, I mean, is that really a smart thing to do, to dump all the water right next to the building and not shed it off? Do you have drains on the balconies? I mean, are you putting in a 150,000 square foot parking deck and all the drains are on the high side? Is that the way to do that? So there's a lot of different things that the checklist points out. You know, flashing interfaces, are there compatibilities? How are the windows constructed, and do they interface with the flashing correctly? Are the laps right on things? And just all kinds of little stuff that when you ask yourself, if you're interested, you can say, did I look at this as a potential for leakage? And at worst, you could delegate this to somebody else and say, hey, you're new, go check off all these things on this list. Let's see, what else do we have for resources? That's about it, but we're going to start putting those on our website so that people can access that and look at it. So some of the things that, how do you get to a problem with waterproofing? Well, you build it. You build it just like you think the plans show. And I want to talk about some of the most common problems that we see with, especially with below grade waterproofing, and where these problems occur that you tangle with the most. Below grade waterproofing nowadays is a little more complicated and goes in phases. You have typically, you used to have below grade waterproofing on just the exterior walls. And now with, especially this rainy season, we've had water tables creep up a little bit. And so you might have a building that's 5 feet above the water table in Austin. Well, it ain't no mo. It's about 10 feet below the water table. So what happens? Well, you look under the sink in an apartment complex and water's going up through the pipes. And you go, I wonder if the waterproofing on the walls is going to work. Probably not. If you have water shooting up out of the floor, you're probably going to have some other issues. But if your waterproofing stops out here and you really need it to totally envelop the building, it's a design issue. It's nothing you can fix. And I have people that call me all the time and say, hey, do you have something for this? And I said, yeah, it's pixie dust, hocus pocus juice. There's a couple products that over the years we used to call a spray and pray. They work pretty good. They're very expensive, like $100 a gallon. But if you spray it on and you go to church and you sprinkle holy water, it'll stop those leaks. But so design of a below grade structure, if you don't have it designed right and if it's not meant to be submerged, it's not going to perform well. And that's really not our fault as builders and installers of those systems. That's as a design issue. And certainly if you have a blown geotech report and you think the water's way down somewhere else and it's not, that's an issue. So, but that's fairly uncommon, but it does creep up, and when it does, it's a really tough thing to try to fix. The other thing is, you got your below grade footings and foundation and structural members that support the walls and the slab. Those generally go in first. And sometimes they're encapsulated in waterproofing and sometimes they're not. They typically have, or should have, a water stop somewhere in that construction assembly. It could happen vertically, it could happen horizontally. we find a lot of places where those water stops are installed incorrectly or not at all. And that's a big thing. Because if you just have a below grade wall waterproofing condition and there's no water stops in the wall to slab or wall to footing assembly, you can have some problems there, and you say, how do I solve that? Fortunately, grout injection is a good way to solve it, but even better than that, put the water stops in and put them in correctly. So we see a lot of those problems and coordinate the water stop installation. And of course the French drain installation too. I love to see like below grade foundations and they have the French drain and it goes in a circle. Or it doesn't daylight anywhere. So you got a French drain, and where are you taking the water to? Well, we're taking it down the edge of the building about 300 feet, and we're going to daylight it. So in order to get 1/8 inch per fall flow on that French drain, the water's got to be 8 foot tall in the middle of the foundation to get any flow to the end of the French drain. Little things like that make water stops even more important because you're compromising those locations there. So that's where we see a lot of repair efforts going into, is this slab to wall connection kind of stuff. And you could have a foundation down here. But you know, where is the waterproofing supposed to start and stop is a really important thing for us. How does it tie into something around the grade beam? Because building that sounds really easy, and design professionals are really good about drawing lines around it, but how do you install that in a neat form, a hole? You're gonna have a single-sided form, or you're going to use the earth to form up those footings. How do you line that with the waterproofing that's supposed to be impervious and have no holes? A little bit tough to do. So those details aren't just ones where you call at the last minute and go, hey, I got my concrete coming tomorrow and I need you to get out here and put this detail in. That takes a little bit more coordination than sending out a guy with a couple rolls of stuff and hoping he puts all the connections together. All the details are really, really important. So we see a lot of repair required there. We see a lot of repair required when you have slabs that drain water toward the building. And a lot of other places where we have either crappy details or missing waterproofing. Here's an example of we had this come up 10 years ago, and then we had it come up 10 days ago. And it seems like we just never learned. But here's a pier that's right next to a wall. So how do you waterproof behind that pier? And the architect has said, I want that to be XYZ product. Okay, so I know you want that to be XYZ product, but that product won't go behind that pier. I don't have a guy skinny enough, no matter how little I pay him, I cannot starve him to be flat enough to fit in there and get that waterproofing between the pier and the wall. I know some of you guys think that that's not true, that we do starve enough to fit a guy in there. But so you could fix this detail, but you may not be able to use a sheet membrane waterproofing. You may have to encapsulate the whole pier. There might be a bunch of different ways you have to do that detail. So those are the interesting kind of details. Also, one that we have a lot of trouble with, and I know everybody else does. You know, it's hard for general contractors to recognize it because you've got all these 35, 40 trades, you're throwing stuff up, it's schedule, it's budget, it's changes, it's all documentation. But when you work your way up the wall, and all of a sudden you transition from one type of waterproofing to the next, like a blindside application to a freestanding wall application, how's that transition happen? Well, you better plan that before you pour the wall. Because now how do you dig through there and find that transition where you go from wall waterproofing to from blindside to freestanding wall? Well, you know what you do? You grout inject the heck out of it. That's what you do. So that's a tough condition that has to be planned as well. Where does that transition happen? When does it happen? How do you detail it? And not very many manufacturers, I don't think any manufacturer details that worth a darn. How do you make that transition? Well, it's really easy. Look at our standard details, and it's not. So those kind of transitions are tough, and they make it difficult. So between the designers and the manufacturers, they go, here's what it is. It's a standard such and such a detail. And then we get out there and go, well, man, I covered it up. That's covered in shotcrete. How do we get down there to make that connection? Well, you can use bentonite, or you can use urethane foam grout, a couple other things. So those are the kind of things that certainly trade damage is tough. I don't expect, you know, when I worked in other trades when I was younger, I didn't know what waterproofing was, and I didn't care. And if my job was to dig something, then If it moved with a shovel, it was removed. I didn't care what it was. What is that stuff? I don't know. Somebody told me to dig, I dig. So we see a lot of that where maybe the guy running the backfill, compacting the backfill, doesn't understand that if he compacts the backfill right next to the waterproofing, he will tear it off the wall. He doesn't know it, and no one will see it because now it's buried. So you dig it up 3 years later and go, why does this building leak? Why is all this waterproofing crunched up and bunched up right next to the wall? Oh, were they backfilled? And it's those kind of things. So, so that's how we get to these problems that that are hard to fix. And some of them are so hard to fix that, yes, the first course of action would be to dig it up and do it right. But that is not always the case. If you have a 40 by 40 box, concrete box, that's underneath a 60 by 60 building footprint, you're not going to tunnel in 20 feet around that whole perimeter to fix that waterproofing once you put the floor on top of it that's bigger than the bottom. You're hosed. You've got to fix that leak in that lower part of the building, not by tunneling under, but by some other means. And so some of the repair products that we use, and some are changing. The most common ones, bentonite is not a bad deal. Bentonite clay, I don't know if any of you, if you're all familiar with it, it comes in blankets, it comes in cardboard. That's hot applied in that thing that's stuck to it. It comes in bags. If you snort this, it'll give you a really bad headache. So I wouldn't recommend that. It comes in sheets, and what it does, I put some in this cup of water. So this piece right here is on a plastic sheet, and you put it between the soil and the concrete, and it expands and turns into this sloppy gel. This sloppy gel, when it's compressed between the soil and between the soil and the concrete, becomes impervious to any more water. Loads up. This will get to, I think, 6 to 10 times the size, its normal size. This will grow. It'll grow into itself and make a solid wall of snot that is impervious to additional water, and that's how it keeps water out. Now, sometimes if we've had like a bunch of pipes going through a building, like instead of having the conduits that go into a electrical vault or something underneath the building, instead of having them 6 inches apart where you can detail them properly, just stick them all in one big mess and say, here, waterproof around that. Well, you can't. You can't get in between all the pipes. So you can take bags of bentonite and just dump it in there and swell. It'll make a big impervious ball of stuff around those pipes. So that's a good thing. So this is what that bentonite looks like. It's really slimy, and if you want to touch it, feel it, you certainly can. But we use bentonite. It's inexpensive. It's inert. The neat thing is it doesn't have a chemical problem with anything else. So if you're going to put it next to asphalt or silicone or metal, I mean, it might make the metal rust, but it's not going to have a chemical reaction like a urethane or a PVC or something else would. One of the other most common ones is cements. And John will talk about that. There's cementitious products, some that grow crystals, some that are hydraulic cements that heat up, and there's some with microfine cements. They're plugs. It's a plug for most of them. Others with the crystal, they'll grow the crystals in the concrete, they'll bond better. It's one of the only products that you can use on the inside of a wall once the water comes through. Now the bad thing is the water is in the wall and it does have some deleterious effects with the rebar and everything else. But if you're 20, 30 feet under a building and it's going all the way over here and you can't access that wall, this is a very important product to have in your bag of tricks to stop a leak. And then you would treat the corners with a hydraulic cement, and there's a bunch of other things. But you can fix a below-grade leak from the inside using cementitious materials. Let's see. Now, some of the weirder ones. Are you familiar with the Deka? So that's a weird one. Is it bentonite and butyl?
It's butyl rubber and urethane.
But it swells.
Yeah.
And it'll swell up, and so if you have a crack that you can access, you can shoot this stuff in it. I've repaired dams at lake bottoms and ponds and stuff like that, where it was going to be covered up, and I had one shot to do it. Bentonite needs confining pressure. This does not. So that's the difference with this product here. Another one is you have these liquid flashing products. This is like Proseco's product. They have liquid flashings. It's silyl terminated polyether, which is it's a silicone augmented polyurethane type of product. It's liquid. It's like it's sealant, except that you can put it on something wet, or you can wipe it off. It doesn't have a problem with water. So you can fix a through-wall flashing with this here, and it probably is not going to have a chemical reaction with it. And these are gun grade or trowel grade. And here's the thing that's interesting about these. Now you have those are air barrier products. But occasionally you have a waterproofing application where you say, man, I can't wait for it to get dry. I need to access it faster. Those will work on some types of applications, and certainly you could use them for a failed air barrier to make a flashing repair. A couple of years ago, Proseco came out with an augmented product of this that's semi-self-leveling. Now these are a specialty weirdo product, and this is the neat thing about when you work with different manufacturers, they tell you silly stuff they have. This is a semi-self-leveling, slow to medium cure silyl terminated polyether. So let's say I've got a bunch of, this is like a multifamily or a hotel fix. You have a window frame that's leaking. You can inject this into the window frame and it starts to self-level, especially if it's the corners of a window frame that have been over-trimmed and you have leaks in the corner of those window frames. You can inject this in the window frame, it'll start to self-level out, and then it'll set up. It'll set up in about 5 minutes. So instead of running out everywhere like a self-leveling would, this will start to self-level, and it could fix a window without having to tear the whole thing out or tearing the ethers of the plaster out. Pretty interesting product. It's very pricey, but it's a lot less expensive than ripping the face off a building. So there are some new technologies out there that you'll see that could be used in some applications. Most of them are pretty old and tried and true, but every once in a while you got that magic. This is pixie dust here, I think. They made this stuff special for me for a project, and I couldn't convince the owner that that would be the best fix. They said, no, we're going to tear it all out. Okay, it wasn't my job, which was really good. But this is an interesting project. So I'm going to turn it over to John because he's got more experience with all this stuff. But I just want to let you know there's a lot of things out there that if you do have a building where the primary waterproofing system has been blown, there are repairs that are substantial enough to give that building the full life it's supposed to have. John?
Well, I think you pretty well covered it. I think we ought to all go drink. And I got one thing to correct. That's not oxygen. I carry my nitroglycerin tablets in there.
Did you see nitrous oxide?
Nitroglycerin. And you notice, Dan's respectable. He wears a white shirt and he gets to tell you about things that go above grade. They keep me below grade. So I really should title this Below Grade Waterproofing Leak Repairs. Two things. If y'all want to get up and go get in a beer or something else to eat, go ahead. It's not going to hurt my feelings. One of the things is when you get to be my age, you really don't give a damn anymore, So, and the other thing, there's several people in here that probably know as much about this as I do. Mr. Kane, Mr. Moore over here, people have been doing this a long time. So if I say something wrong, go ahead and correct me. It's not going to hurt my feelings at all. Okay. This is not a sales presentation. I just want to acknowledge the people that made this possible for me to do it. Resiplast is a manufacturer of polyurethane chemical grout. They manufacture the Speedtech line, and they're the ones that provided a lot of the information that I use. Okay. Methods of sealing primarily below grade leaks, although you can use them in some above grade applications. We have chemical grouts, crystalline waterproofing, Dan mentioned, bentonite grout, and then what I call other methods. Things that are a little bit quirky, but I am going to mention them to you. What are chemical grouts? If you do not know, chemical grouts, no one could really define it. I mean, you can have sodium silicate, you can have polyurethane, you can have acrylamide, you can have acrylate. There's all kinds of things that can be chemical grout. Whoever originally named them was just trying to differentiate them from the cementitious grout like you use under machinery and equipment and things like that. Corps of Engineers 30 years ago tried to define it, as the Corps of Engineers is wont to do, and they said the chemical grouts are injected into voids as a solution and react after a predetermined time to form a solid, a semi-solid, or a gel. And I guess that's as good a definition as anybody could offer. There's nothing magic about this, although I one time had I went to call on the leading geotechnical engineer in the whole state of Texas. He's in Houston. In fact, his nickname is Dr. Dirt, and he's very knowledgeable. And I tried to get to see him and tried to get to see him and tried to get to see him. That's when I was younger, and now I just give up. But finally he said, I'll give you 15 minutes. I'll see you at 4:45. You know, Houston traffic, 5 o'clock. I said, I'll be there. So I walk in, and it's just he and I, and we go back in his conference room, and he's got on a t-shirt, and he's dirty, and he's got mud on his boots. And I lay my catalog up there, and he picks it up, and I start into my sales spiel. And he's leafing through my catalog, and all of a sudden he takes it and he drops it in the trash can right in front of me. I said, Dad, you got a problem? He said, I don't believe in smoke and mirrors. Well, a lot of people believe that chemical grout is smoke and mirrors. It's not. All you're trying to do is you're trying to pump or get this liquid product where you want it to go, wherever the water is, and just hold it there long enough to react. Because it's going to react with water. There is no way that it cannot react with water unless it's, you know, bad material. Somebody made some bad material. These products always react with water. How do we use it? Well, Dan mentioned some of the things, some of the causes. The biggest use for chemical grout is and always has been crack repair, crack injection, basements, foundations, in the water and waste industry, filter basins, clarifiers, anything that is either trying to hold water in or keep water out. In addition, sometimes you can't do the crack injection, you have to do a more general application, and so we have something called curtain wall grouting, where we drill through a below grade structure and we inject the chemical grout through the wall and build a membrane in situ. Pro-grouting is actually curtain wall grouting, but instead of drilling holes through a wall, you go outside the structure and you install it by putting strainer pipes down into the ground and injecting it that way. That's not something you all in the waterproofing normally get involved with. That's more of a geotechnical type application. Two big classifications of grout, and this confuses people because we in the industry haven't explained it well. It's our fault that people are confused. You have hydrophilic grouts and you have hydrophobic grouts. Both of them react with water. Both of them want to react with water. The hydrophilic means water loving, and what this means is these grouts, after they react, after they form the foam, they still have up to 25% water in the foam. Why is that important? Dan mentioned the water table going up and down. Back in 2011 we had a drought, the water table was way down all over Texas. 2015 we had a lot of rain this spring, too much rain, the water table came way up. Hydrophilic grouts, if the water goes away, the grout will shrink. If it had 25% water in it before, if it loses all that water because the water table went away, then it's going to shrink up to 25%. The hydrophobic grouts, hydrophobic means water hating. They still react with water when they're liquid, but once they have reacted and formed a foam, they only have about maybe 3 or 4% water. So if the water table goes away or you drain the tank, whatever it is that you're using it for, they will not shrink. They are what they are and they stay that way. I mean, I am totally biased. I've been doing this since 1984, 31 years. I believe in hydrophobic grouts, and I don't like hydrophilics, but hey man, I drive a Ford. I saw some nice looking Chevrolets and Dodges out here. They're all good trucks. Both these products will work if they're properly installed. Another way to classify grouts is single component and plural component. All that means, that doesn't mean you got an A and a B like an epoxy. It simply means that single component grouts can be run through a single component like a Graco 395 ST. Plural component products do have an A and a B, and they have to be installed with a plural component pump. The reason this is important, it's important to you guys, is these things are about $3,000 and these things are about $15,000 to $20,000. Big difference. So, now, this is not a sales pitch, but I'm just showing you, and I'm going to mention this again later. There is no one, people say, well, just recommend a product, one product. Well, you can't recommend one product for every application because each installation is a little bit different. You could have wide cracks, you could have narrow cracks, you could have moving cracks, you could have static cracks. One manufacturer, SpeedTech, has 1, 2, 3, 4, 5, 6, 7 normal products that we normally sell and use. If you looked at the whole catalog, we probably got 25 products. I bet Don sells 30 or 40 different products. I mean, they have a huge range of products. Avanti probably has 30 products. So there is no one product. I mean, you can't just stock one product and install it because you're going to get in trouble. Crack injection, like I said, is by far the largest single application. It's pretty simple. I'll show some pictures. You have to create an entry port into the wall. You have to intersect the crack somehow in the wall. And you can do very, very tiny cracks. You can do, if you have a good pump, you can do cracks that are a 64th of an inch wide. You can't even hardly see them, but yet you can inject them. And it allows for you to work from the negative side. You don't have to tear up the landscaping. You don't have to drain the tank, whatever. So you can get all of this work done from the negative side. How do we choose then? I just said we got all these different products. How do we choose? Well, if you call me, or if a consultant calls me, an engineer calls me, and says that they have a water leakage problem in a basement, in a tunnel, whatever, and they want a recommendation for a product, I'm going to try to find out what is the cause of the cracking. Has someone looked at it? Are these structural cracks, or are they just shrinkage cracks, movement cracks that are causing leaking? Are they moving, or are they still? Are they static or dynamic? Will there be wet-dry cycling? Because I just told you, if you have wet-dry cycling, then we definitely don't want to use a hydrophilic. So I have to ask that question. What is the rate of leakage? There's a big difference between choosing a grout if you've got a weeping crack or if you've got a 50-gallon-a-minute crack. So what kind of flow do we have? How wide are the cracks? And not so much in your business, but I do a lot of work in the chemical plants and refineries down in Pasadena and Deer Park, and the temperature of the water plays a big part there, because some of that water is almost boiling. Most cracks move. In the state of Texas, one thing I found out in the 31 years I've been doing this is unless it's a crack in a massive spread footing or a pile or a pier or something, or a dam, most cracks in the kind of buildings that we work with where the concrete is 6 inches to a foot thick, most of them move, especially as you get farther towards the Gulf Coast, because everything on the Gulf Coast has Bowmanite clay. Bowmanite clay is the substrate, and that stuff swells and contracts, and those cracks do move. Up here, or in central Texas, if you get on the limestone, you have a good solid foundation, you might have cracks that have no movement. You also have to be aware of cracks where there's a compressor or a generator running close by, or a lot of traffic, truck traffic, because you get a lot of vibration. That causes the cracks to move also. So you have to choose either a rigid grout or a flexible grout to match whether the crack is moving or not. Why do we use flexible grouts so much? Well, They can be injected from the negative side. You don't have to do excavation. They react with water, so you don't have to dry it out. You know, in fact, we prefer that when you do the injection, that water be coming in, water be flowing, everything be saturated. You're going to completely fill the cracks and voids. Dan mentioned, and I show you a picture. If you use crystalline waterproofing or hydraulic cement, smear it on the wall, stop the leak, owner's happy, everybody goes home. You still got water in the wall. The structural steel is still corroding because it's still in contact with water. These products, most of them, of the good manufacturers, their products remain flexible for many, many, many years. So I'm a real fan of flexible grouts here in the state of Texas. With the cracks is important. Each of the manufacturers, Neef, Avanti, Speedtech, each of them has a medium viscosity product that you use for credit card width cracks and wider. Most of them run somewhere in the 600 to 620 centipoise range, but all of the manufacturers have super low viscosity products that are about half of that, and we use those in cracks that are only, say, less than a credit card wide. And you say, why? If you got a real good pump, an airless pump, and it'll go up to 3,000 PSI, you can push this stuff into a hairline crack. But you're going to have to run that pump somewhere north of 2,000 PSI. And I just don't like that if I don't have to do it. Because that packer could blow out of the wall. There's a lot of things that could happen when you're pumping at high pressure. So if most of your cracks are either wide or narrow, it's best to go with the product that fits the physical dimensions of the crack. Now, some of you may have done epoxy work. In fact, several of you may have. With epoxies, when you're injecting cracks, you glue a little hat on top of the crack, and then you pump at very low pressure, 20, 30 PSI, something like that, and you let the epoxy flow all down through. We don't do that with urethane because the urethane starts reacting the minute it hits the water. And if you have a fairly thick wall, and you have water running through a crack, and you're trying to pump against that pressure and all, chances are that urethane is going to set up before it gets through the wall, and you're not going to fill the entire crack. So the best way to approach it, if any of you remember your high school geometry, obviously it's harder for me to remember it than it is for people your age, but 45-degree right triangle. If this is a 12-inch wall, and if you came out 6 inches and then drilled back towards the crack at a 45-degree angle, you should hit that wall should hit the crack right about in the middle of the wall. You say, why do I want to do that? Well, then, here we drill, here we hit the crack about in the middle of the wall. When we start pumping the grout, it goes both ways. It fills the entire crack from the middle, and so your chances of getting the whole crack filled have just increased by about 50–60%. So I think that it makes a lot of sense. It's a lot of work. And man, out there on a hammer drill with a heavily reinforced wall, you got big old number 8 rebar or something, and you hit that bar with that hammer drill, it feels like an electric shock. I mean, it is no fun. But believe me, this is the best way to do it. We also don't want to drill all of our holes on one side because cracks seldom go perpendicular, totally perpendicular. So if we drilled all of our holes from this side of the crack, we would miss a great deal of that crack. So you start on the right or the left, and then you switch back and forth. It's called stitching. And you drill from each side, therefore you should get at least half of those holes into the crack.
Can I bring up something, John?
Yep.
Another important thing about starting to pump the grout in the middle of that crack is because sure you want to stop the water from coming through the wall on the negative side, but if you inject that right, if you have a breach in the waterproofing on the other side of that crack, you're going to pump that grout and it's going to breach the crack in the waterproofing as well as the crack in the wall.
Right. That's true.
So you're repairing the waterproofing, not just at the source of the failure, not just at the source of where the water's coming through the wall.
Absolutely. So people ask frequently, well, how far apart do I put my holes for the injection? Well, on most of the work, most commercial work, I recommend that you put them on 1 foot centers. That seems to work pretty well. You seem to get really good travel from port to port. Occasionally we can get by with 2 foot centers, and I realize why you might want to drill fewer holes, because it costs you less labor, it costs less money. Owners are not real happy about you drilling in, especially into a new wall. So if you can do it with 2 foot centers, God bless you, go ahead and do it. But if you ask me, I would normally start on 1 foot centers. I can tell you this, if the entire crack is this thickness, then you could probably do the 1 foot centers. But you notice where the crack gets narrow. Frequently you will be forced to go onto closer spacing, because you won't be able to push the grout through. You won't be able to get complete penetration unless you tighten up your spacing. So it really depends on the conditions of the crack that you are working on. This is just an example. This was a below grade wall. They had a leak down here. The crack was very tight and narrow. Up here it was kind of pie shaped. It got wider. So they started out on fairly close centers, and then they spaced it out as they went up. Okay, cold joints. Cold joints we can treat differently. Hopefully the cold joint is a known configuration and is perpendicular to the surface. Now I realize that, like Dan said, things don't always get built like they're supposed to. And I'm sure that there's joints that are not perpendicular to the surface, but we can normally assume that they are. So in this case, you got a keep joint. You can drill right in here, hit the crack here, and then pump it, and you should get good flow both ways. Now, if something was in the way over here, piece of machinery, something, then you could drill in this way. And here I would want to hit it on both sides, because it'd be problematic to pump it from down here and have it come all the way up, or here and go all the way down. So there's 2 options for treating that cold joint. And then if you couldn't get to either of those sides, then you have to do the best you can. So you come in and you try to hit it somewhere as close as you can here, maybe over here if you could, and pump it that way. But joints should be a little bit more regular geometry, so they're a little bit easier to predict. Now here's one that ties into what he was talking about in the drawings. Let's pretend that there's no water stop, or it's a failed water stop. But here we have a floor and a wall perched on a spread footing. We have some kind of water source. It could be a water table, it could be a leaking pipe, whatever. We've got water out here. Water is coming in through this joint, up through this joint, and into the occupied space. Okay, how do we treat it? Well, you know, you could drill way up here and drill down and hit it here, but it's a whole lot easier just to come out here. If this is a 6-inch slab, you come out 3 inches, whatever, and then drill it at 45, and you actually hit both of those areas, and you can inject them and get them both at one time. Now, you have to know something about how the structure is built, and sometimes people just give you that deer in the headlights look when you ask them, you know, how's it built? But if you can do a core, or if somehow you can determine, here's one a little bit different, where the floor sits on the spread footing, the wall sits on the floor. So we don't really care anything about this joint down here. I mean, unless there was some reason that the owner wanted the water out of here, normally this is what he's interested in. So we just come up the wall this time, half the distance, half the thickness of the wall, drill it at 45, hit it in the middle, and pump it, and it should take care of the leak. Now, this will tie into what Dan was talking about with your crystalline waterproofing. Let's use a dam holding back water as just an example. This could be a basement wall, and this could be fill, wet fill if you wanted to do it that way. But let's just go along with the dam hypothesis. We have a leak. Okay, we have a head pressure and we have a leak. Now, you can come in and you can put hydraulic cement or crystalline waterproofing on the negative side over here, and you might be able to stop it. Now, if you've got a whole lot of head pressure, you're not going to stop it with either one of those. But let's say that you were able to get it stopped, at least temporarily. The problems are, you still got water in the structure. The structural steel is still corroding, it's still saturated with water. If you're up north, it's not so bad here in Texas, but if you're way up north, you can have freeze-thaw problems. You can spall concrete due to freeze-thaw. You can also get a lot of wicking because the water is still in there, and it's probably going to find some secondary cracks and paths to follow. So I think it makes a lot more sense. It's a lot more, and you're dependent on the bond, whether it's chemical or physical, you're dependent on the surface bond to hold that patch on. Now, if you come in and you inject it, that same leak, and you fill that crack, now the flow path is completely filled. You don't have any water left in the structure. So the structural steel is protected. Primary seal is over here on the positive side, and you got a full depth bond all the way down that, however thick that is. So I think this is a whole lot more permanent repair. Now, it is very possible that this repair will cost considerably more money than smearing something on the wall. And you know, the owner's in charge, and you go to him and you say, $10,000 to inject the crack, $3,000 to put crystal on. He's going to say, how long will it last? You say, maybe a year, and he says, go ahead and do it. Well, then you go ahead and do it, because it's his structure. But it makes a whole lot more sense to fill the crack and get the water out of the structure. And this is just an example. This is a little bit hard to see. This is a tank. You see water up here on the other side. And here the guy has set his packers, and he's screwing the packers. Well, not, actually, he's doing the injection now. And he's working his way up the wall. He's got a nice ladder there. I don't know why he's standing on tippy toes on top of something, but I guess, you know, that's the way it goes. I don't know what OSHA would say about that. But he did a pretty good job, because now we're looking down on the wall, and he got good penetration of grout all the way through the wall. In fact, he got some grout plumes out here in the water. So we would assume that he completely filled the cracks and stopped the leaks. So to wrap up crack injection, step one, clean the surface so you can see the crack. If you can't see the crack, if there's white lime deposits and dirt and everything all over it, you can't even see the crack, it's pretty darn hard to seal it. So we need to open it up, grind the surface off, chip it, whatever. First question comes up is, do I need to surface seal? Can I just go ahead? With epoxies, you always surface seal. With the urethanes, it's not required, but if you have a really wide crack, you're going to use a whole lot less urethane. You're going to have a whole lot less cleanup. Now, a whole lot less labor cost for cleanup if you surface seal. But for a tight crack, it is not required. Step two, here's the crack down here. He's drilling his injection hole at a 45-degree angle. Step three, I like to see them come in after they drill the holes and just take something, take a squirt bottle, take a pump-up sprayer, wash those holes out, because you got a lot of fines left in the hole after the drilling, and that prevents the packers, which I'll show you in a minute, from really seating well and sticking good. And step four, install the packers. All of these are different forms of packers. And if you ask me which one's best, I can't answer that. Once again, we're back to the Fords and Chevys and stuff. I have, you can pass these around, take a look at it. They all do the same thing. I have contractors that swear by the regular mechanical packer, 1/2 or 5/8. Other guys pay the 30% premium and use high pressure packers, even if they're not pumping high pressure. I said, why? Well, I get better flow. If you open that bag up and look, the hole in the middle is the same on all of them. The flow's the same, but they think, okay, that's fine. Plastic bang-in packers, the little plastic ones there, I am not a fan of. They will not take a lot of pressure. They're going to come out of the wall, but they are much, I used to say cheaper. I was informed you're not supposed to say that if you're in sales. They are less expensive. They're cheaper. Some people like Zerk fittings, which are grease fittings, and some people like the button heads. Once again, it's entirely up to you. It makes no difference in how they function. First thing we do after we got the packers installed is we pump water. Because you want to make sure that you've got flow all the way down the crack. Water is fairly cheap. It's not as cheap as it used to be, but it's cheap compared to the grout. The grout's pushing $50 a gallon. Water's not that expensive. So first you pump water, and the other reason you pump water is to get the concrete wet, because remember, these products only react with water. So if you don't have water coming in, you're going to have to wet the concrete to give the grout something to react with. So first we pump water, then we mix up the product. And I didn't give you my usual lecture on safety, but for God's sakes, if you're working with these products, wear goggles, wear gloves. I prefer long sleeves. If you get it on your skin, it's just annoying. You have to wear it off. If you get it in your hair, you have to cut your hair to get it out. But if you get it in the eye, if you get it in your eyes, you're going to the hospital. You very easily lose your eyesight if you get your eye is water. Your eye is 80% water. The product starts reacting with your eyes immediately. So you definitely want to keep it out of your eyes. Now, this is what happens if you have a fairly wide crack and you don't surface seal. Now, all you guys that are contractors, if you want to pay somebody to clean that mess up, that's up to you. But if you just take something cheap like hydraulic cement and smear over the surface, it cuts down on a lot of that loss of product. So, but once again, that's your decision. After you finish, after you clean up the surface, you pull your packers out because the owner wants you to fill the holes, make it look nice. I really recommend that you shoot a little water into those empty holes, because you're going to have some unreacted grout left in the holes. It just makes it neater, makes it easier for you to put in your patching material. Question, how much pressure should I use? I can't answer that, because how tight are your cracks? Are you getting good flow? What kind of pressure does your pump develop? But you want to grout at the lowest pressure you can and get flow from packer to packer. If you can do it with 250, 300 pounds, then just use 250, 300. It might take 1,000. Use 1,000. For God's sakes, don't start at 3,000 and work your way down. I've actually seen people do that. Cranked it all the way up. Man, they had stuff squirting everywhere, and then they started backing it off after they had made a mess. The other thing is, how much should I pump? I have seen specifications with all of these criteria in them, in different specifications. And he said BS was Bachelor of Science. Well, in this case, BS is bullshit. This is bullshit, this is bullshit, and this is bullshit. Seriously. Pump it till they won't take anymore, and you cut the water off. I mean, that's pretty simple. Some of these engineers, boy, they really get this God complex, and they want to build this specification that no contractor can possibly break my spec. And all this other stuff is really meaningless. Pump it until it won't take anymore and the water stopped. Pretty simple. Curtain wall grouting, instead of cracks here, I'll show you pictures. It's better than reading all this. Basically, you're punching holes in the wall and you inject the grout through the wall into the substrate, and you build a membrane in place. Why would I do this? If you have a wall that has so many cracks that you can't possibly identify every crack and drill it and set packers and inject it, then it's probably a candidate for curtain wall grouting. Masonry, stone, and CMU walls are also a candidate. Right now we have a job in Austin. It's one of these lube places, Jiffy Lube, whatever. If you've ever been in one of them, you drive your car in, and below it they have another room. That's where the guy goes. That's where the oil runs when he drains it out and everything. This Jiffy Lube is built with CMU below grade walls. They're not filled, unfilled CMU below grade walls. Man, it looks like a river running through that thing. And so now this guy is going to spend, the owner is going to spend a boatload of money to get it fixed. Maybe the owner says, hey, 3 or 4 people have injected this wall, cracking, that stuff doesn't work. Well, then curtain wall grouting is a possible alternative that will please him. You have to understand a little bit about the way it goes. If this is a wall and this is a hole you drill, when you inject the grout, it does not form a perfect circle like this. This is ideal. This is not what you get. You actually get, gravity takes over, and you actually get these little bell-shaped mounds. Once again, ideal world, if you injected up the wall, you would stack all these grout circles up, and they would all touch, and everything would be fine. But actually what you're doing is something, as you move up the wall, you're getting something that looks more like that. Now, you always start at the bottom. Don't ever start at the top. The reason is, if you inject grout here first, it's going to fall. If it falls, it's going to create voids, and you're going to continue to have leaks. A lot of people want to go in and create a real nice checkerboard pattern, line up all our holes vertically and horizontally. That doesn't work. The reason is that as you inject, you're going to have voids where the little bells don't meet. The way you want to do it is you want to do a diamond pattern, and that way, as you inject, everything is going to together, and you're going to wind up with a continuous membrane. So here's the gravity flow. If you had the circles, perfect. Now, as I said, there's no silver bullet. There is no one product. I wish there was, but there's not. It's kind of like the hex head bolt deal. If you're trying to remove a head bolt from an automobile engine or something, a hammer and screwdriver is probably not a very good idea. Although in my youth I tried that. Pipe wrench is also not real good. Crescent wrench is fair. Open-end wrenches and a socket wrench is an excellent choice. Well, if you're trying to stop high water flows, multi-ratio urethanes are not a good choice. Hydrophilic urethanes are not a good choice because they tend to just wash away if you have high flow. Acrylates are fair. Hydrophobics are good, and if you really got high flow, 2-component urethanes are excellent. So there is no one product. Now the packers we mentioned and I passed around, they're all in that bag. You've got the mechanical packers, the bang-in packers, and the high-pressure packers. They all serve the same purpose. Here, a lot of people prefer these button head packers. You can get them with a plastic button, you can get them with a Zerk, and you can get them with a stainless steel button. Once again, it's strictly personal preference. These are all different types of specialty packers for particular applications, which you don't really care about right now. How do you connect to them? If you're using something with a Zerk grease fitting, then you want a Zerk connector. You can buy those at auto parts stores. You can buy them at an Allenite distributor. You can buy them at any place that sells tractor equipment. If you like the button head type of arrangement, then that's what button head connectors look like. This one has a neoprene seal. This one has a nylon seal. And everybody used to use grease guns on the end of their hoses coming off the pump. I really think that high pressure ball valves, which I need to get a picture in this presentation of, a high pressure ball valve is less expensive and it'll take a whole lot more abuse, and believe me, these things do get abused. Most holes are drilled with hammer drills. Every now and then I see some guy who's just gone in business come out with his DeWalt wood drill, and that lasts about 2-3 hours on the job, and then he's going to rent a hammer drill. You can do it with a, can I do it with a grease gun? If you have a small job, if you have a little job, you got 10 feet of crack, and if you're healthy and young and you got a good bicep, yes. But just make sure the grease gun is clean, that has never had any water or moisture in it. For plural component products, they even make plural component grease guns. Oh, that's a weird one. You can, if you're just getting into business and you don't want to spend $3,000 on a hairless, different manufacturers, different people sell hand pumps. It's a step up from a grease gun, but it's still going to work the heck out of you. And if you got a big job with 12, 16-inch walls, it's probably not going to work. They also make hand pumps on a dolly for a plural component. The people that are really in the business, though, that do this every day, all day, and I'm not selling Graco equipment, that's just what I have a picture of. I think Sherwin-Williams has Titan. I believe that Sherwin-Williams sells Titan. There are other manufacturers, Wagner, different people, but this type of pump is kind of the workhorse of the chemical grout industry. And for plural component and acrylates and things like that, you can get up into these things, which are, like I say, $15,000, $18,000. Last thing on chemical grout. I know you're about to go to sleep. I actually want to go home. Soak in place. Any of you ever heard of open soakum or soak in place? Any of you ever done it? It is the dirtiest, nastiest thing. It's kind of like cleaning out porta potties. It really is. But I'm going to show it to you because it works. If you got a wide joint, like this, if you try to seal the surface and inject that thing, you are just going to make a mess. You're going to waste a lot of product. Some of it's going to free foam on you. You're not going to wind up with a good tight chemical grout seal. So we need some way of getting the chemical grout into the joint and holding it there so that it can react. So the industry calls it oakum soakum. If you want to be correct, it's saturated oakum or saturated backer rod. You can use oakum, you can use open cell backer rod. And this shows you how old this slide is. With the price of cotton, only a fool would try to use cotton. Anyhow, here's an example. I don't know why they picked roof slab, but we have a slab of some sort. And we want to seal it because we want to put a membrane over it. Okay, you go in and you shove a closed cell backer rod in the back. The closed cell backer rod the diameter needs to be 1.5 times the width of the joint. So if this is a 1-inch joint, you need a 1.5-inch diameter backer rod. Shove it in good and tight. Then you saturate either some open cell backer rod or some oakum rope and shove it in here and react it, and it'll seal that joint, and then you clean off the excess and you can put your membrane on. Now, I'm going to one-up Mr. Kane on this one. He said if you snorted that, he said if you snorted that bentonite, that it would really make you sick. Well, this is oakum. Oakum is unoiled hemp rope. If you roll this and smoke it, man, it's great. That would be a doobie and a half. Might not come back to you. That's right. Hey, I want that back. I got to spend one more night in a motel room. That's mine. So here's a picture of how they do it. I told you it was nasty. You got to wear gloves and everything. You put the chemical grout in a bucket, pour some in an open top bucket. Take your backer rod, your open cell backer rod, saturate it with water, and bring it out, and then take your hands and you work it in like you were washing clothes or something, and you saturate that rod with chemical grout. You bring it out, you wipe the excess off, and then you take it and you shove it, physically shove it into the joint. That's what they're doing there. Then, since this stuff's going to expand, and you don't want it to go everywhere, and you want it to be as dense as possible, put a 1x4 or 2x4 on top of it, put some kind of weight on top of it, and just leave it alone. And here you can see where it's expanding underneath there. But what you formed is a gasket. You formed a gasket in place. Okay.
So it also works real good, and beneath has that pipe plug kit.
Yep.
If you have a conduit going through a wall or a sleeve and it's leaking, and it's not even enough to put a link seal around it. If you have a failed link seal, you can pack cotton or backer rod around there and put grout in it. It's still a penetration in a wall.
What I'm passing around here is this is some samples of reactive chemical grout. Those of you who have never been around it and never seen it, these are made in compression. If you just mix it with water in a cup, it foams up and it looks like shaving cream type foam. But if you confine it in a crack or in a void or in a joint, you wind up with something actually denser than even this, because we have to make these in plastic bottles and then the bottle breaks, and so you never do get it totally reactive.
And you sell more of this on Alpha jobs or Chamberlain jobs?
Gotta be Chamberlain.
Jobs. Okay, alternate materials. Dan mentioned some of them. Crystalline waterproofing. Crystalline waterproofing, and I think y'all, there's Vandex, there's Zypex, there's Kester, there's, Aquafin. There must be 20 of them on the market today. Some of the big boys, BASF, Sika, some of those people are even have them, don't they?
Expand their product.
Everybody's got them. They are surface applied. Well, normally you would be a surface applying. They're a negative side application. You do not need to do excavation. Now some of them have flexible coatings and things, but most of the basic crystalline waterproofing products are rigid. They have limited head pressure. What I mean by that is if you got water squirting out of that wall 20 gallons a minute, it's pretty hard to take that masonry brush and spread the crystalline waterproofing on there, or even pack it on and hold it. These are situations where you have fairly limited water flow and fairly limited head pressure. The application equipment is really pretty minimal. You've got a drill to mix with, a couple of buckets, some rags and gloves, and a masonry brush or a margin trowel, and you're in business. They're really most effective as an admixture if they're added to the concrete as the concrete is being placed. If they will use them as an admixture, they can really densify the concrete and cut down on porosity. Most of the manufacturers sell systems. They have coatings that go over their crystalline waterproofing. I think those are fairly effective and hold up pretty well. But sometimes if somebody applied this stuff and they really glued it on, and then it's 6 months before they coat it, and you get a lot of salt formation, you can have some serious surface coating adhesion problems. So just be aware of that. Back to what we were talking about, we went through this earlier. We're still trying to address the same problem. This is a surface applied material. You're depending upon the surface bond to hold it, and you still have water in the wall. That's the real problem with these materials. But if the owner says, "God damn it, get the water out of my elevator shaft or my basement," I think they're pretty effective. Here's an application, and I have to admit I plagiarized these, or I stole these off of Zypex's website, so I could have something to show you. But here's a guy with a masonry brush, surface applying the crystalline waterproofing. That's a wall application. Here he has plugged a leak. They each make a specialty material. It's kind of like hydraulic cement in that it's very fast, but it also has the crystalline products in it. And you basically just shove it in there and hold it and stop the leak. It depends on how long it takes. And here's one that we did. This is kind of hard. I apologize for the photography, but this is an elevator pit, and these three of the walls were actually block, and one of them was concrete, and it had a curb at the bottom. And they were treated with crystalline waterproofing. I do not know whose. It doesn't make any difference. And the crystalline waterproofing did a really good job of keeping moisture from coming through the CMU walls. I suspect they were filled. But it did not do well at the bottom, and I suspect it was an application problem because each of these manufacturers has a very detailed system for cutting out a joint, packing it, doing all that. But the bottom joints continued to leak. So we wound up having to drill it, set packers, and inject it. But a lot of times I get involved in jobs where we use a combination of crystalline waterproofing and chemical grout. And mainly that's done because if they had used chemical grout for the whole thing, the cost would have just been prohibitive for the owner. So he was able to seal the really crucial areas with the chemical grout, which is mainly the joint where the wall and the floor met. And then he was able to surface seal the walls, and it worked pretty well. Bentonite slurry. Dan showed you the bentonite membrane. Well, Setco in particular is real big in the oil field business. That's a huge business for Setco, and they use their bentonite there, and they mix it with cement and some other additives, and they actually make a grout. And this can be used in our business if you have a wall and there's a void. There is a definable void, let's say a big void, on the positive side, the outside of the wall, for whatever reason. You can inject the bentonite grout and you can fill that void, and as Dan said, then the bentonite swells and you actually build a pretty substantial membrane in place. I think it works pretty well. You have to monitor your pressures really carefully, and the equipment is not equipment that a waterproofer would normally have, but you can certainly rent it. You have a moino pump, and you have a mixer, and they mix the grout, dump it into the rotor-stator, a moino type pump, and then you pump it, it's just a slurry, and you pump it into the cavity between the wall and the fill below. And basically, I mean, there's a technique certainly, but if you follow their guidelines and all, as it reacts, the cement gives it some strength and physical geometry, and the bentonite swells, and you wind up with a pretty good membrane. Now, in our business, we just got through saying you can't always dig up the parking lot and all the foundation planting, but you can do this from the negative side, from the inside. Instead of drilling little bitty holes like you do 5/8, ½ inch for the chemical grout packers, you wind up drilling a larger hole. But you can pump this from the inside. See, it can be done from the inside, and I think it's pretty effective. I think it's not cheap, but it. And then we got some miscellaneous materials, and I don't want to step on anybody's feet and hurt anybody's feelings or piss you off before you go home, but I put hydraulic cement up there. I am not a fan of stopping leaks of any magnitude with hydraulic cement. I'd rather see you use crystalline waterproofing. But if you just need to temporarily stop some water from coming in so you can work on something, obviously hydraulic cement will harden and stop it. There is a product, it's rubber based, it's called Turbo Seal. I don't know, Dan I think's heard of it, knows about it. Don I think knows something about it. I really can't tell you a whole lot about it, but it is a flexible material. It has a rubber base, and as I understand it, it never fully hardens. So it should be there, and it should be able to bridge cracks and seal cracks for an indefinite period. I think it requires some special equipment, doesn't it, to install?
Yeah, it's not very expensive to pump it, but it is a special pump. And then, yeah, it tends to self-level. It's somewhere between a gel and like a hot applied water.
Okay.
So it's semi-fluid. You heat it up to pump it, but not really hot, just less than 200 degrees, and then you can pump it.
The only job I've been directly involved with it was actually here in Dallas. I won't name it. It was a tunnel, and it was sealed with Turbo Seal. The problem was the Turbo Seal was exuding some sort of oils. So instead of water leaking into the tunnel, it was the oils. And we actually injected with chemical grout to stop the oils from coming in. But anyhow, it is there. And then epoxy resins are sold for structural repair. Chemical grout is sold for waterproofing. But I will have people come up to me anytime I do like ICRI meeting, I address say, well, I stop water with epoxy. When I was younger, I used to say, "You know, you didn't." Well, then I was made a fool of, because yes, they can. If you don't have a lot of flow, if you can dry the concrete out to some degree, and if the guy really knows what he's doing, you can inject epoxy resin into a crack that has been leaking, seal the crack, and it will resist the water in the future. But it's a whole lot harder than doing it with chemical grout, because those epoxies are moisture tolerant, but they won't go over standing water. So if in the pores, if down in that crack you still have liquid water, the epoxy is not going to bond there, it's not going to react right, and you may have the leak come back soon. But if you can dry it out, and if the guy knows what he's doing, there is a couple people here in the Metroplex that are really good at epoxy injection. You can seal cracks with it, but that's not the primary application. But you know, any questions or any comments or anything I said that was totally wrong or irritated you?
What do they do for verification? How do you verify? I mean, other than the water stops, you know, what if you stop it in the wall and now it's coming in underneath the footing, or
Well,
you know, in between the footing and the maybe not detectable?
If you suspect that there's water, if the water didn't stop, then obviously you know that it didn't work. But if the water stopped, if the basement's dried up, but you still suspect that there's water coming in, the wall is just not getting in, the only way I know to do that would be to core it. Get an engineer, someone that's trained in doing that, and core it. Then you got to patch the core. But
The water, if you inject and you stop the water in one place, it's going someplace else.
Oh, yes.
Because if you have a leak coming through this part of the wall, it's still going other places. And if you stop the leak at that one place, the water's going wherever the rest of that water was going in the first place. Hopefully to a subsurface drain, or hopefully the place it was supposed to be directed to go in the first place.
that's true. Example, this Jiffy Lube type place in Austin. The owner had a hard time understanding. He did not want to pay to have a curtain wall all the way around that basement, let's call it, and because he said the water comes from the east, it doesn't come from the west. And so the contractor tried to explain, and he finally got me to drive over there and talk to the guy and explain that we're not getting rid of the water, we're stopping it from coming in. It's going to come around the corner, it's going to come down the sides. So he finally bought injecting or doing a curtain wall down the sides, one end and the sides. He just would not hear of it on the west end. So I said, fine, but if you start getting water in the west end, remember, we told you, we can't make the water go away. All we can do is stop it from coming in. But if you suspected what you were talking about, the only way I know of to do it would be to core it. You could run some kind of moisture test to see, compare it to an area where you knew there was no water coming in. That would be less expensive and less destructive. And if it was a slab, you could actually do one of the moisture vapor kits on it and compare it to an area that you knew did not have water.
We find that when we grout inject, 25% of the time, we chase the water down the wall or someplace else. So the water is in a 1/4-inch crack over here and it's coming out very freely. So we dam up everything within a 6-foot location of that 1/4-inch crack, and now it's coming over here in a crack that's a 16th of an inch. That's very common. A lot of times people get all excited because, hey, you did grout injection and now you moved the water down the wall. Well, no kidding, that's the way it works. So typically, if we have 100 feet of crack, we're going to stop at 75 feet, and out of that remaining 25 feet, when we inject again, now we're going to have it still leaking 5 feet. So it's you're chasing the water down until you can eliminate it. If you expect one shot to happen, it's probably not going to.
And then the one thing that Dan has never listened to me on, I said, Dan, do not work on parking garages at condominiums in Midtown where they have Lamborghinis and all parked below the crap, because you can't win. There's no way. If the owner of the Lamborghini wasn't bitching about the lime and the calcium dropping on his hood, And of course, they always want the whole car detailed, not just the hood. Then, sure enough, you're going to get some chemical grout on there, and boy, then you were in trouble.
Now, the 1985 Chevy that's got all primer on it,
Yeah.
they'll never park that underneath that crack.
That kind of leads to my next, how do you correct the deficiencies? Let's say you pump this thing full of epoxy or grout or whatever,
Yep.
and, you know, do you just go back through and drill, you know, where it didn't, you know, penetrate or, you know, give you satisfactory results?
Well, if you had an area that did not, if you had an area that where you didn't satisfy the requirements, then what I would do is go and I would drill and inject in that area some more. Chances are, if what you suspected was true, when you drill that hole, you're going to get water out the hole. So you're pretty well going to know that, yes, you're correct. You did not get the water out of here.
Robert, unfortunately, you can't just guarantee that you spend this much money, use this much grout, and inject this crack and stop it.
Yeah, that's
Yeah, it's a blindside
down the wall.
It's a blindside fix.
Re-injection is really difficult, and frequently you have to go with a lower viscosity material. Let's say you were using the 600 to 650 centipoise medium material, and you have an area between these two packers where you didn't do the job. You go back in, you may have to go with the lower viscosity material in order to get it to penetrate, because now you've got reactive grout in there, so that's going to inhibit the travel. Re-injection is difficult. I mean, that's where you really get down to the nitty-gritty.
All right, and then one last one. What do you do when the movement's severe? You got half an inch between your two slabs. Well, now it's two slabs. You got to go in there and raise it up and get it back level before you can even start with the waterproofing.
You can either go in there in mud jacket, or I didn't get into it because it doesn't usually affect the waterproofing contractor, but there are chemical grouts and equipment for jacking and leveling. Best known company in that business was Eurotech for years. They actually had a patent on it. And now that their patent expired, so anybody could get into it. But you're going to have to do something, either mud jacking or something, to bring those into alignment.
A combination product where it seals it up and bring it back up level?
If the contractor had that expertise, yes, it will do both.
As we see more continuous insulation like XPS and EPS on the exterior of some of these concrete and CMU walls, are there any of the chemical grouts and such that cause an adverse reaction and will re-liquefy the XPS or EPS, or is that kind of unbridged territory at this point?
There's no solvent. Oh, I can't speak for everybody's grout. In the old days, that's how they got low viscosity. 3M was the first company in America to actually produce chemical grout in America. All the technology came from Asia and Europe. But 3M got the low viscosity by putting 25% acetone in their product. Boy, it stunk to high heaven, and it would melt, stuff like that. As far as I know, Denif, Avati, Speedtech, I don't think any of them have any solvent in their grouts anymore. But they do all and have to contain plasticizer. That's how you get a flexible urethane. And some of the plasticizers will go right through like a plastic bottle. So I would say that you would need to check it with whatever it's going to come in contact with, because it is possible. Now, I have never had a case where they said it's doing this. But some of the old liquid applied bituminous products, when you shot the urethane in there, certainly if it had acetone in it, it just emulsified it, just turned it to liquid again, and some of the plasticizers would attack those. But that's a good point.
If you had
I don't think polystyrene, I don't think it bothers polystyrene, but I don't know what other plastics are in some of this stuff. EPS is expanded polystyrene.
Right.
I don't think it bothers that, but if there's other plastics, that it very well might.
EPS and XPS are both polystyrene, and then polyiso are the three main rigid boards.
Yeah.
So polyiso is a little less susceptible to chemicals versus the polystyrene.
Turn it back to you, sir.
Well, John, thanks for coming out here.
Another thing I mentioned, the International Concrete Repair Institute's National Convention is in Fort Worth in the second week in October this year. So if any of you are #1 into concrete repair, or it's not pure waterproofing like the other, yeah, but they have a lot in there about things like chemical grout, repairing things and all, and they're going to have some excellent program over in Fort Worth this fall.